Let's see this. They have given that logical address space equal to 16 bytes, and they have also given that it is a byte addressable system. Okay. Now my question is, what will be the length of the logical address? Okay, in bits. I want to know how many bits will our logical address have. It is very simple, right? 16 bytes is nothing but 2 power 4 bytes. Fine. Now, in order to indicate 2 power 4 bytes, assuming that every byte is given an address, we need exactly 2 power 4 addresses, right? In order to generate 2 power 4 addresses, we need 4 bits, right? We need 4 bits. Now, how did I get this 4 bits? It is very simple. It is nothing but log of 16 base 2, or this can be written as log of 2 power 4 base 2, and this can be written as this 4k will come front, right? 4 into log 2 base 2. Log 2 base 2 is nothing but 1, and so I got the answer as 4. Okay, this is how we got the answer as 4 bits. This is fine. Now what if the logical address space is 15 bytes? Okay, what if the logical address space is 15 bytes? See, in case of 16, we are able to actually indicate them using 2 in terms of 2 power, and so we are able to get the log as 4, right? Now in case what will happen over here is, if logical address space is 15 bytes, then the size of logical address is nothing but log of 15 base 2, right? Now log of 15, what is the value of log 15 base 2? It is nothing but 3 point something, right? 3 point something, which means if log 16 base 2 is 4, whereas log 15 base 2 is 3 point something. Now we cannot say that I need 3.5 bits, right? There is nothing like half bit or quarter bit, right? Either I can have 3 bits or I can have 4 bits. Now with 3 bits, will I be able to, now tell me whether the answer is 3 bits or 4 bits. The answer has to be 4 bits. Why? Because with 3 bits, I cannot definitely indicate this, right? I cannot indicate all the 15 bytes. But with 4 bits, I can definitely indicate all the 15 bytes, right? Which means with 4 bits, there are 16 combinations possible. 0, 0, 0, 0 and so on, right? Till 1, 1, 1, 1. There are a total of 16 combinations possible, out of which I will use exactly 15 and I will leave one of them, okay? Need not be this combination, it can be any combination. So in order to indicate so generally we actually remove the last combination, okay? By convention, we take the first 15 combination. So what I want to tell is, log 15 base 2, though it is 3 point something, we need exactly 4 bit in order to generate the logical address, because using 3 bits I will be able to generate only 8 combination, okay? In case if I get only 8, in case if I have only 8 combination, I will be able to give addresses only for 8 bytes, but I need for 15 bytes. So I have taken this as 4 bytes, okay? So that is what we mean by sealing, okay? 3 point something. In case if I have 3.75 or whatever it is, 3.85 or whatever it is, in case if I apply seal to this will make this as 4, okay? Whereas in case if I take floor of 3.75, what will happen? This is nothing but 3, okay? That is the difference between seal and floor. In case if I take sealing 3.75 will become 4. That's the reason I'm saying that if logical address space equal to m bytes, then size of logical address will be equal to seal of log m base 2 bits, okay? Seal of log m base 2 bits. The same explanation also holds for physical address space, right? If physical address space equal to n bytes, then size of physical address will be equal to seal of log n base 2 bits, okay? Seal of log n base 2 bits. Now one question you might ask is, why logical address space is not given as a power of 2? I told that everything in computer science will be in powers of 2, right? Even logical address space should also be in powers of 2. Yes, what you said is perfectly correct, which means in practically if you take any computers, everything will be in powers of 2. But this is just a theoretical concept, okay? It is not practically possible, which means we are not using like 15 bytes or 200 bytes or whatever it is. We are going to use only in powers of 2, which means 128 bytes, 256 bytes, 16 bytes, 8 bytes, 4 bytes, all this, okay? But still, in case if we get a problem like this, we need to solve it like this. Okay, that is what it is, just to know. But but practically we use only in powers of 2. Okay.